All right, so in this lesson, we're going to describe relationships in terms of coefficient, well, in terms of a correlation coefficient. So basically, in the last lesson, we talked about correlations and we talked about causality. Basically, we talked about how two things were related and if one thing was the cause of another thing happening. So, correlation coefficients. Before we get into that, let's talk about correlations and what they look like in terms of a scatter plot. So if you see as the x-axis increases as we go to the right, the y-axis increases, it goes up. So we're going upwards. This is called a positive correlation. Positive. We can tell on this one, as the x increases, the y increases. We have another positive correlation. In this one, it's a little weaker, but generally speaking, as it increases, as x increases, y increases. In this one, we can see that all the dots and the points are all over the place. So there's no correlation, right? No correlation. In this one, there's a weak, well, we'll get to weak in a second. This is negative because as x increases, y decreases. You can tell because it's going downward. Same here and same here. That's why these are negative correlations. The question is, like, how, well, I guess, what else can we tell from this? Now, you see how this is like basically a perfect straight line? That's what makes it perfect. It's like very strong, like super strong relationship. If we look at this one, if we were to draw a line on that one, is perfect. If we were to draw a line through this one, see how it's like a little looser? That just means it's not as strong as this one. It's pretty strong because they're pretty much like all around this line. So that's why it's still strong. If we try this one, they're a little like looser, and this looser means it's weaker than the strong and the perfect one. The same thing goes with the negative correlations. If we try to draw a line through here, it's all scattered around it. It's not very clumped up like in a perfect line, so it's weak. We can tell in this one, it's better. They're pretty clumped around this, so strong. And this one, of course, is pretty strong because it's like, straight line through it. Now, those are the correlations and how they show up. But what does the coefficient mean? This coefficient is a number. This number tells you how strong or weak it is. So for instance, let's look at this positive one. You see how we can like put a straight line through it, perfect straight line? Well, remember, this is a positive because we're going up. This is a positive because we're going upwards, or shown by going upwards. This one means this is perfect line. That's a 1. So in this one, over here, all the way on the left, you're going downwards, but you can see how it can be perfect. I'm not great at this. Let me try again. You can see how we can sum this up using a straight line going downwards, right? So we know it's negative, and it's perfect straight line, so it's 1. Now, if it's all over the place like this one, that means the number is 0. There's no relationship, no correlation. Now, if it's close to being like a straight line, I know that's not perfect, but it's pretty close. It's 0.8. If it's perfect, it's 1. You see, like, we'll start from here. 0. This is weak. It's even hard to see, and see why. That's why it's 0.3 positive, and this is positive 0.8, and this is perfect positive 1. You can see this is negative 1, but I like to start from 0. So 0, this one's kind of weak. That's why it's negative 0.4. This one's, I guess, a little better. Still looks weak. I would have said it's negative 0.6. But the point is, the closer you get to 1, the straighter it gets. The closer you get to -1, the straighter it gets. But a +1 means it gets straight while going upwards. A -1 means it's going down. It's going to be perfectly straight going downwards. So let's go ahead and look at some more examples. Remember that this is the perfect one, because perfect line, going upwards. Downwards, perfect line, -1. This one is all clumped together, so it's pretty close. I wouldn't say 0.98, but I'd say like 0.9, you know. This one's weaker. Oh, this one's weaker, but I guess looser. I wouldn't even say 0.69. I'd say like 0.6 or something. This one is like very loose. It's even hard to see. I would have even said this is maybe no correlation, but point is, you can see that the straighter the line, the bigger this digit is. Closer to this to 1. And then the +1 means it goes upwards, -1 means it goes downwards. Alright, so let's look at some problems. Okay, we can see that this has to do with piano practice. So on the x-axis is the time spent practicing in hours. So this number goes up 1 hour, 2 hour, 3 hour, 4 hour, 5 hours practicing. These are the number of incorrect notes. Okay, so these are the incorrect notes. So the more you practice, it looks like usually the less incorrect notes. So first things first. This is going downwards, so this is a negative correlation. We read from left to right. So as the time spent practicing, I'll put in hours, increases, the number of incorrect notes. Number of incorrect notes decreases. As this increases, this decreases. Now I'm going to attempt to draw a line. Downward lines are always an issue for me. They're kind of clumped up, right? I mean, I could draw my line a little better, but they're kind of clumped up. I'd say it's pretty strong looking. So I'd say it's between strong and very strong, somewhere in there. Now, that's our strength of that's my predicted strength. Now, causality. If we look at this, as you practice more, should the number of incorrect notes decrease? So as you increase time practicing, you play less things wrong. So they're definitely related. I would say they're pretty causal. The more you practice, the less you mess up, right? Related and probably causal. All right, one more. I'm going to try to draw a line in the middle of these. Remember? In the middle somewhere. Remember, even though this wasn't perfect here, I was aiming to get to the middle. So as temperature increases, shuttle launches increase. So positive. So as temperature, which is in degrees Fahrenheit, increases, the number of shuttle launches also increases. Okay, now this is. Oh, I gotta check something real fast. Okay, they're clumped up. Looks medium strong, maybe strong. I want to put medium strong, somewhere in there. I don't know what temperature has to do with shuttle launches. Maybe in the summer they have more like spaceship launches. I don't think summer causes it. I think people like just make that decision. So I'd say they're related, temperature, because maybe the summer they do more, but the temperature doesn't cause the shuttle launches. All right, so if you have any questions, let me know. Thank you.